Now in the Greek numeral system, again, I have 1017. And so to do this, you can pull up the Greek numeral system. Right. And you can work from left to right. It doesn't matter, right to left. I'm going to do left to right. So I have this 1, which isn't one thing, but 1,000. So I remember ones, tens, hundreds, and then I repeat to get the thousands. So I should probably write alpha, comma. And then I need to figure out how to represent, there's no hundreds, so I don't need to put anything there, but then I have a 10. So how to represent 10 things, I come over here, and I look for 10, and it's iota, so it's like an I. So I draw an I. And then I need to do 7 things, because this is 7, and this is zeta. Zetas are hard to draw. I'll do my best here. So here's my zeta. Right, zeta's right here. Okay. That's supposed to look like that. All right, so that's 7 things. Notice there's no symbol for 0 in the Greek numeral system, so you just leave it blank. Right? Just put an I. Just put an I there, which represents 10, and then 7. So that's 1,017 things. In the Greek numeral system, this is relatively simple. So I have to pull up, the Roman numeral system. So 1,000 is an M. And then I have to get 17 things. And so 17, I can do an X for a 10. I can do a V for a 5. And then 2 ones, right, for 17. So 1,000, 10, 5 is 15, plus 2 is 17. Now we want to take a number like 87 and represent it base 5, and then represent it base 2. Right? So 87 is in our base 10 numeral system, so we can take 87. And to represent it in the base 5 numeral system, remember we have to figure out basically, how many 1s, how many 5s, how many 5 squareds. And then we don't need 5 cubed, because 5 cubed is 125. Okay, so how many 5 squareds, right? So 5 squared is 25. And so obviously we can put 3 25s into 87. Right? 3 25s is 75. So what we have left, 5 gets me to 80 plus 7. So we have 12 things left to represent. And so for it to represent 12 things, we can put 2 things here. So that's 2 5s, so that's 10. And then 2 here. Right, so you have 3 25s, 2 5s, and 2 1s. And so that gives me 3, 2, 2. And we put a little 5 down there. Right, to tell everybody that this is base 5. And the base 2 numeral system, so 87. Right, we're going to need lots of spaces here. So we have a 1 space, a 2 space, a 2 squared space, which is really 4, a 2 cube place, which is really 8, a 2 to the 4th place, which is 16, a 2 to the 5th place, which is 32, and finally a 2 to the 6th place, which is 64. And then 2 to the 7th will be too big. It'll be 128, and we don't need 128 because 87 is smaller. So what you can do is you can say, okay, I put a 1 here because I can put 164 into 87, and then you subtract to see how many things you have left. Okay, so you can take 87 minus that 1 represents 64 things in that spot. So 1 minus 87 minus 64. So I have 23 things left. This means I don't put anything here because I can't put 32 into 23. But I can put 16 into 23. I can go into it at least once. All right, so that if I take off 16, because by putting that 1 there, I represented 16 things, what I get is 7 things left. So I put a 0 there. I have 7 things left. And then I put a 1 here. That's 4 things. So now I have 3 things left. I put a 2 here. So I had 3, now I just represent 2, so I have 1 thing left, and I put a 1 there. And so 87 base 2 can be written 1, 0, 1, 0, 1, 1, 1, and then you write a little 2 down here to tell everybody that this is in base 2. Alright, so moving on. now we want to do addition in base 10, base 5, and base 2. And so now to add 21 and 7, it works in base 10 just like you learned. So 7 plus 1 is an 8, and then you carry down the 2, right? And so you get 28. Obviously 21 plus 7 is 28. Now let's do this base 5. And the idea is, instead of using your base 10 addition table, which you sort of internalized, we're going to use the base 5 addition table, and we haven't internalized it because we don't usually count base 5, but it's given to you, so just read it and use it. So 1 plus 2 is 3. Okay, so it's just like we have in our base 10 numeral system. But 4 plus 1 is going to be different, right? 4 plus 1 isn't 5 because we're in base 5. It's actually 1, 0, like a 10 in a sense. So you get 1, 0, 3. And then, of course, we write a little 5 down here to tell everybody that this is base 5. Okay. Base 2 now. Let's pull up the base 2 table. Alright, so on base 2, what we have is this base 2 table here. Let's just get rid of that. Okay. And so we add these using the base 2 addition table. We don't really need the multiplication table at this point. And so what we have is 1 plus 1, and 1 plus 1 is a 10. So the way we do this is we write a 0 and carry the 1. And then 1 plus 0 is 1. Right? 1 plus 0 is 1. And then 1 plus 1 is 10. So again, you take the 0 and you carry the 1. Now you have a couple choices for this column. You can say 1 plus 1 is a 10, so just carry the 1. And if you add 1, you get 1 here. You could also say 1 plus 1 is 10, and if you add 1, you get 11. So write down a 1 and carry the 1. Then 1 plus 0 is 1, and then just carry down the 1. And so we get our answer of 1, 1, 1, 0, 0, base 2.